Hello everyone, today my team, which consists of myself, Chai Yan Bin, Ling Jun Xiong, and Rico Yan Xie Kang, will be talking about the Bloomberg European Headquarters Energy Efficiency Review. So first of all, let's go over a general introduction of Bloomberg Headquarters Europe. Bloomberg Headquarters Europe is an office building in London designed by Foster and Partners that opened in 2017 located at the 3 Queen Victoria Street. It has won multiple awards such as the Reba Sterling Prize 2018, BREEAM Awards 2018, D&AD Awards, Lighting Design Awards, and BCO London Awards. Now let's move on to the first system review, which is the lighting system.
Moving on to lighting system. Bloomberg's lighting system features an innovative ceiling panel, LED lights, and sustainable materials. 2.5 million innovative ceiling panels were used, combined with chilled ceiling and LED lighting technologies. The integrated ceiling panels features the pedal-shaped aluminium that minimizes the amount of light block, improving performance, energy efficiency, and reducing costs. The ceiling sufficiently and evenly manages acoustic reverberation across the open-plan offices. The sculpted shape maximizes surface area to significantly improve heat exchange and optimize airflow to maximize convection. In addition, the slot within each pedal improves overall energy transfer. Bloomberg also includes skylighting in the middle of the building, which reduces 40% power consumption of daytime lighting and allows passive solar gain that contributes to 15 to 20% of CO2 emission reduction.
The Bloomberg European headquarters facade boasts an innovative design that utilizes bronze fins. These fins offer both unique aesthetics and energy-saving benefits, such as solar shading, which helps in reducing solar heat gain and glare while allowing natural light to filter in. Additionally, the fins incorporate acoustically treated vents that provide natural ventilation, improving indoor air quality and reducing the need for mechanical ventilation. The bronze fins on the facade are also designed to optimize natural daylighting, reducing the need for artificial lighting and creating a better indoor environment for the occupants. The fins are positioned at different angles and depths, which maximizes natural daylight while also minimizing glare and solar heat gain. Finally, the building's design includes a central atrium that allows natural light to penetrate deep into the interior spaces, reducing the amount of artificial lightings needed at certain times of the day.
Moving on to the HVAC system, there are 3 main categories which is incorporated into the building, namely the combined heat and power system, ventilation system, and building management system. A fuel source, fossil or renewable, is combusted and the energy produced is used to drive a prime mover engine or gas turbine, which produces mechanical power and heat. The mechanical power is converted into electricity via an alternator, and the heat is available to use directly or converted to meet its requirements of the site. The CHP system delivers improvement in energy efficiency, reduction in energy costs, and an improvement in the site carbon signature. Typically, a CHP system achieves energy utilization of 70 to 80%, which is a significant improvement over conventional electricity and heat production, with some CHP systems achieving energy utilization up to 95%. This improvement in efficiency lowers the cost of production and produces a lower carbon signature per unit of energy produced. Waste heat generated from this process is recycled for cooling and heating, and in use is expected to save 500 to 750 metric tons of carbon emissions each year. Depending on the fuel sources used, such as biogas or hydrogen, it can deliver a carbon neutral or negative position. The CHP also provides flexibility in operation to manage energy demand and supply. The building uses a hybrid ventilation system between natural ventilation and mechanical ventilation. Outside air will enter the floor plate through the building's bronze fin facade, which is able to control the airflow through its opening and closing of the fins. The office is also mechanically ventilated with air supplied from the rooftop AHUs. Additionally, the building uses flow bar diffusers to maximize ventilation options like supply, exhaust, and the returning of air. The HVAC system of the building is controlled by the building management system that uses sensors and data analysts to optimize energy usage and reduce waste. It uses a smart airflow where each floor incorporates 60 to 70 integrated CO2 zonal sensors linked to the BMS. It allows air to be distributed according to the appropriate number of people occupying each zone of the building at any given time. The ability to dynamically adjust airflow in response to occupancy hours and patterns is expected to save 600 to 700 megawatt hours of power per annum, as well as reducing carbon emissions by approximately 300 metric tons each year.
Lastly, waste management. To reduce its environmental impact, Bloomberg headquarters uses a comprehensive waste management system that incorporates technology for composting, recycling, and waste to energy. The system they implement combines with innovative vacuum drainage system and cooling tower recycle water. The vacuum drainage system uses a difference in air pressure to transport of sewage from toilets to a vacuum unit. This system as a whole uses between 0.8 and 1 liter of water per flush in comparison to the traditional gravity system that use up to 6 liter per flush. Together with the cycling of cooling tower water, rainwater harvesting, and the cycling of grey water from shower and hand wash basins, enable all water closet flushing to be undertaken through the use of cycling water and rainwater only. This enables the building to save over 25 million liters of water annually.
Lastly, the post-occupancy evaluation of Bloomberg's European headquarters showed that this innovative and environmentally friendly building received very high scores in BREEAM ratings, demonstrating its commitment to sustainable design. Its ventilation system featuring bronze blades that can open and close, allowing natural ventilation along with its smart airflow systems, allows for an annual power saving of 600 to 750 megawatts per hour and a reduction of 300 metric tons of CO2 emissions. The Bloomberg's building waste management system is notable for its 1 to 6 water utilization in a vacuum drainage systems, which resulting in zero potable water use. The vacuum flush toilets are filled by rainwater, cooling tower blow-off water, and grey water sources, saving 25 million liters of water annually. The innovative lighting system with 2.5 million petals operating as light reflector for 500,000 embedded LEDs, which saves 40% more energy than standard office lighting. Finally, the building's energy saving system uses a single, effective system with lower carbon emissions from an on-site CHP generation facility, generating waste heat for cooling and heating and prevent 500 to 750 metric tons of CO2 from being released annually while also saving 35% of the overall energy consumption. With that, this concludes the energy efficiency review of Bloomberg's European headquarters. Thank you for watching.